We'll talk a little bit more about, I guess, some of the technical side of our farming operation, some of the studies that we've been doing, and really how our farming has had an effect on water quality. As farmers, if you paid attention, the last several years we're making national news. Algae blooms in the lakes, nitrates in our water tables, having issues with water quality and effects on it. But really the big thing is if you use cover crops, it'd be a lot cooler if you did. Make sure y'all are awake before I start. But really for us, this is how it starts. I mean, how many guys are cover cropping and doing multi-species? How many multi-species do we have? I really can't stress enough, even if it's 2 or 3 different seeds in there, a lot of guys, I call it the training wheels. You start with wheat or barley or rye. You start out with a single species, but just the amount of benefit that we're going to get from having a mixed bag. This is just, what we're looking like on the home run blend. This is some of our summer cover crop mixes. How many guys are grazing, how many farms are grazing cattle on summer cover crop mixes? Any of them? The biggest thing that we found out, 2015, again, that year the drought taught us a lesson. These BMR varieties are really good for forage quality, increasing our forage quality. The BMR does really well. But the problem is if you get dry or if you get hot, they really just don't perform very well. So we actually started doing a little bit more diversity in these mixes. We're mixing like a regular sorghum Sudan with a BMR. Same thing, just use like a standard, like a pearl millet with we really like that new Exceed pearl millet. That one's done pretty well. And then some cowpeas and different sun hemp varieties. But, as far as water quality goes in my home county, if you work for Soil and Water, you may have heard this before, but our county was really ahead of its time as far as no-till goes. We actually did really good with no-till until this implement came out. I really have a love-hate relationship with a turbo till. The one thing that I hate is what it does for the soil structure. Guys were talking about doing no-till, then they started buying turbo tills, and our Catawba River system is what they call a 303D classification, which means we have sediment from top to bottom in the pool. And we really didn't see that come around until guys started running these equipment. The one thing that I do love about a turbo till is farming on hilly ground. My neighbor sends me free topsoil and nutrients every year. And I actually send him a really nice gift card. It's kind of just a little jab there at the end of the year, how much we were able to save. But I mean, this is typically the real erosion that we're seeing in my neck of the woods. And it's kind of crazy to me as farmers that we're still seeing stuff like this or the dust storms that we're seeing out in the Kansas, Colorado area. But the one thing that I say about tillage, I understand it as a farmer. We have vegetable production. We have issues as farmers where we're wet at harvest time and we're going to tear ground up. Like I said, last year when we had 100 inches of rain, I had the same issues my neighbors did. We still made ruts in the field, but instead of disking the whole farm, we would only take and try to fix those tracks up the best that we could. And we've had neighbors that are still doing inline ripping and subsoiling, and it's just not paying off when we're actually doing some of these tests on our farm as well. But there's not one single thing that tillage does that doesn't destroy at the same time. And the biggest thing that I like to tell people when I go speak, it's about frequency and intensity. If you're growing a crop that requires tillage, try to prolong that crop rotation where we're seeing less frequency, and then also look at the types of tillage that we're using as far as the intensity of the machine. And that really has had a big impact on our farm as well. And to give you an idea, this is typically what we see. A lot of guys, when I go to their farm, we dig a shovel full if they're doing tillage. There's absolutely no aggregation there. The soil is starting to collapse on itself. You can see that there's moisture pretty much in the middle of the sample here, but the top of it's already started to crust over and dry. This field here was actually at Darren Williams' farm in Kansas. We went to his neighbor right across the fence row, and this is what his neighbor's farm looked like. And then on Darren's side, this is what Darren's soil looks like. We really don't have a runoff problem in the United States. It's more of an infiltration problem. You'll see some slides coming up where we've seen huge increases just getting our soil to start getting aggregated like this sample here. And it's the same thing that we're seeing all across the country. And so this is what my neighbors do. Typically in the fall, if they're going to bed their crops up, they'll go out and we call them a do-all, but it'll pretty much till everything up, make it into a nice powdery bed, and then they'll set their beds up. And, you know, my time here in Wisconsin, I've seen some pretty good fields here in Wisconsin that, you know, it doesn't look like they have a water problem, but this is typically what my neighbors look like all winter long. Either we get rain, occasionally we'll get snow, but what good is that doing me as a farmer? You know, there's nothing good going on there. The water's either running off or it's evaporates off after it sits there long enough. It's not going down into the subsoil and recharging what we're doing. And, you know, as farmers, you know, this is the problem that they have in the season. You know, once they've destroyed that aggregation, once they've went out there and dissed the field enough, they have to come back and they have to cut a channel through the farm just to get the water to run off. And can anybody tell me, you know, as far as cost of production, what's one of the highest expenses that we use as farmers? Fertilizer most of the time. And it's phosphorus. You know, phosphorus fertilizer is the most expensive fertilizer that we have to apply per ton. And 80% of the phosphorus movement that we're seeing as farmers, it's through soil movement. That phosphorus will bind to these soil particles, it runs off the field, and then we're filling up ditches or lakes and streams. You know, then we're starting to see this right here. We've got the Gulf zone. And I never even knew about this stuff until I did start farming, and this is starting to make national news. And when I see stuff like this, it really does remind me of what my grandpa told me a long time ago. He's a John Wayne fan, and it's life is hard, and it's harder if you're stupid. You know, if I have to buy fertilizer as a farmer and apply it to my field, or if you have manure and you're putting manure on your field, you know, you should make sure if you're putting that time and that energy into putting that out there that we're getting the maximum investment out of it and it's not running off of our ground and into the water table. So the biggest thing, you know, about talking about cover crops, and if you're going to work with a seed company, a consultant, an agronomist, or anybody, is what's your resource concern? You know, is it weed suppression? Is it nutrient management? When you call somebody, if I have somebody send me an email or call me on the phone, that's the first thing I ask them. If it's somebody worth their weight, that's going to be the first thing that they ask you as well, because if you can't tell me which one of those that you're trying to work on, I can't really give you, a good tool to use. And I always kind of find it funny. I've heard Gabe Brown say it a few times. It came from Dr. Dwayne Beck, but I didn't choose your wife or your girlfriend, so don't ask me to choose your cover crop. I can kind of make a recommendation and tell you what different species are going to do for either biology or these resource concerns, but it's one of those things where you're just going to have to play around with it on your operation. And so when we look at starting on cover crops, it really comes down to starting with the basics. And the basics really should be, a small grain, a legume, and a brassica. The biggest thing that I talk to producers about are what your carbon and nitrogen ratios. There's one year we planted 120 pounds of cereal rye. We let it get about 6 feet tall, and I thought I had the best cover crop in the world. And I didn't have any weed pressure, but I dinged my corn yield by about 40 bushels. Our carbon and nitrogen ratio was probably 80 or 100 to 1. It just locked up all the nitrogen that was in the system, and it really hurt it. Another thing is never panic. There's always a way to manage it. We had another year where we had a flood in the spring, and that cover crop residue had laid every which direction. It looked like pretty much a plate of spaghetti. We didn't think that we were going to be able to plant through it. So what we ended up doing is we took a bush hog. We went and bush hogged the field and kind of chopped it up into finer pieces. We left it laying out there for about a week and a half, and we were able to plant our crop through it, and we didn't have any issues. So, just to understand that, build diversity with experience and always know that there's a way to manage it. And then one of the things that we've kind of ran into on the nutrient management side, looking at these cover crop mixes, 40 to 1 is pretty optimal. Like Green Cover Seeds has a smart mix calculator. You can put in different varieties of seed. It'll give you a base on your carbon and nitrogen ratio, and it's a really good starting point as a guide. But if you're looking for something as far as a cover crop where you're going to maximize nutrient release back to that first year cash crop, 40 to 1 is really where we've we found is the sweet spot on our operation. And so, to find out about your ground, how many farmers in here have done water infiltration tests on your own farm? Everybody should do this. It's pretty simple. You can see there's a ring here at the bottom. That's actually nothing more than a 6-inch auger housing. We cut it off. You drive it in the ground halfway. And NRCS has some good tools that you can pull off the internet as far as how to do it. But essentially, it's 2 bottles of water and some saran wrap. When I first started farming, our natural forest has a water infiltration rate of about 1 inch an hour. My row crop ground was about 1/2 inch an hour. So, that means if we got anything more than 1/2 inch an hour, I was seeing runoff of the field. This farm right here, this is actually a picture of Ray and me this last spring, about May. And when we were doing this test, it was really, really wet in some parts. But even where it was already wet, we were seeing 9 inches an hour. We've seen some farms that are over 20 inches an hour. And so, the cool thing for me is if we get a huge rainfall event of say 2 inches an hour, 3 inches an hour, I'm still able to take all that moisture and put it back down in the profile where it's going to be available for my next crop because it doesn't do me any good in the creek. And start looking at doing earthworm counts. That's kind of what me and Ray were getting ready to start doing in this picture. When we first started farming, most of the ground that we were tilling, we couldn't find earthworms. You may find 1 or 2. So we started doing these earthworm counts, and we were testing a foot by foot. So we were testing a cubic foot of soil, and on this sample, we found 93 earthworms, which is roughly about 3.3 million per acre in the top acre foot, which was pretty cool to me. That's huge as far as building those earthworm channels, castings for different fertility, and also even looking at how we've changed the CECs in these soil solutions. And so one of the tests that we did, this is actually a test with the University of Georgia. There's 40 farmers from Maryland to Florida. And what we looked at was different cover crop mixtures, no cover crops where we were doing no-till, and then no cover crops where we were doing conventional tillage, either with a disc or an inline ripper. And one of the things, even if you don't live in Georgia, if you're growing cover crops on your farm, you can still use it. It's called the nitrogen calculator. You can Google it and look it up. So you can actually take a biomass sample from your farm and ship it to UGA, and they'll actually tell you how much nitrogen is available in that cover crop, when it's going to break down, how long it's going to be there for that next cash crop. It's just another tool, another management for your nitrogen use in your corn crops. And so what the university wanted to do is we did no cover crops, and we used the university recommendation, just a standard old recommendation for a normal soil sample. And then there's the N calculator, which is the nitrogen calculator for the University of Georgia. And then the one that says in farm, we actually use the Haney test, and that's the test that we use for that nitrogen recommendation as well. And what they did is these little red squares, they actually cut a biomass sample and put it in a mesh bag and set it on a scale, a really small scale in the farm. And every time it rained, we were actually able to measure when that biology was consuming the cover crop residue. We could actually tell how much they consumed because the weight would change in the bag, and they were predicting what the nutrient release was going to be. And then the green and the blue are actually soil probes. We had our own probes in the field, and then the university did too, and we were monitoring how much water we were getting in the ground. So one of the big things that we took away is everything that's solid black is the bare ground and no-till or conventional, and everything with a cover crop has a white dot. We were actually seeing water infiltration go deeper in the profile. We were actually seeing more water go in because typically in the summertime when the ground got so hot, it would crust over. And then if you got a 1/4 inch of a rain or a 1/2 inch of rainfall, it actually even wouldn't show up on the sensors because the ground had crusted off. It would evaporate before it was able to go through that crusting area. And so we learned that cover crops are not all created equally as well from this study. One of the things we learned about was termination time. In my area, typically farmers want to start killing their cover crops about the end of March, and they may be 4 to 6 inches tall. And then we've started pushing ours back to about April the 15th to about April the 20th, and just letting that cover crop grow a little bit more and just get just a little bit higher carbon to nitrogen ratio, we're able to save that nitrogen until later in the season when the corn crop actually needs it. And the biggest thing that showed up was down here it says how much. The big thing that we wanted to talk about was increased infiltration rates. We were seeing a 70% increase of water infiltration over conventional with no-till and cover crops. So what we looked at is over the period of the year, we actually infiltrated into the soil profile about 12 more inches of moisture on this particular farm. So, if you're a dryland farmer, what would you do for another 12 inches? And even if you're irrigating, the average cost in the U.S. is about $10 an acre inch to pump water now. So that's about $120 an acre that you could save just not having to pump that water because we're getting more rainfall in. And so then we look at, some of the economics. I know it's kind of a busy slide, but I'll go through it. The first one is the N calculator, which is based off the University of Georgia. We were shooting for 175 bushel corn on this trial. They used 158 units of nitrogen, 70 P, 60 K, 18 pounds of sulfur. They had a burn down and a post spray. They made 178 bushels. They were pretty spot on where they wanted to be. And then we used the Haney test, and the Haney test said for 175 bushel corn, I needed 80 units of nitrogen, 10 pounds of phosphorus, no K. I only did a burn down on my plot because I just didn't think I had the weed pressure to justify doing a post spray for another 15 to 20 bucks an acre. And I still made 170 bushel corn. And then based on the regular university test, we did 180 units of nitrogen, a full rate of phosphorus and potassium, full rate of sulfur. They even said we needed a fungicide based on the University Scout. And even with all these additional inputs, they didn't make but 148 bushels. And really we contributed this based on the sensors. That ground got so hot that we just started evaporating moisture, and that crop without a cover crop just didn't have the same amount of moisture availability. But the big thing is who made the most money. The nitrogen calculation from Georgia cost $93.50 an acre more than the other two. But if you look at our farmer calculation, our fertilizer savings, chemical savings, if you look at hauling, drying, equipment, everything, we actually made a net profit of about $80 more per acre. And I think that's the thing that I try to drive home is it's about making that money, that net return versus the gross profit. And so what we do on our farm every year, we work with a company called AquaSpy. Anybody in here doing irrigation at all? We started working with a company called AquaSpy. They typically started out just for mostly just working with irrigated farmers, but we wanted to have this data to talk about. And so they make a sensor that goes in the ground 4 feet deep, and every 4 inches we're monitoring soil temperature, water infiltration, depth and rate. We're also looking at electric conductivity. We're looking where we're removing nutrients during the crop season, rooting depth. There's a lot of good information. And so essentially you can see on the right-hand side, this is our check strip that we run through the field. On the left-hand side is where we had cover crops. And so I can essentially go anywhere in the world and pull this up on my phone. This is what it looks like when I pull it up on my iPhone. But we had a rainfall event, and the no cover crop on the left, back home we have a natural hard pan about 16 to 20 inches deep. And if you look on the left-hand side in the green, you can see that the water infiltrated down to about 20 inches deep. And that's typically what we see. We'll see the corn roots get down the most activity will be around 20 inches where the hard pan is. And the same thing happens when we get a rainfall event. It only goes about 20 inches deep. But where we have cover crops here on the right, and you can see that's how far apart they are. There's not a huge difference there. On the right-hand side, you can see where we had cover crops, we're actually seeing water infiltration rates go down to almost 40 to 44 inches deep. So not only does our roots go a little bit deeper, the moisture is going deeper, which gives me more nutrient availability. And these are just some of the things that we're seeing that, justifies what we're doing and the practices that we have on the farm. And so this is what the home screen looks like. On the top is the cover crop. Every one of these blue bars is a rainfall event that was measured by the sensor. And on the bottom is the cover crop, the no cover crop on the bottom. And you can see that there was a time period in the summer where we actually didn't log the same rainfall events. And that had to do with the ground getting hard and crusting over to where that water actually, even though we got a small rainfall event, didn't get in the soil profile, and it wasn't available to the corn crop. And then we also start looking at, different rooting depths. We were seeing with the cover crops, most of our roots were getting between 4 to 44 inches deep. Where we didn't have cover crops, we were only about 4 to 16 inches deep. Once again, that just comes back to show us that we do have that hard pan issue and a compaction issue that we're trying to break up using these cover crop roots instead of steel. And then the same thing goes, this is the electric conductivity. I can actually map out where our corn is pulling nutrients from the profile. And the big thing to take away is at the very bottom of both of these, where we had a cover crop, our corn roots went so much deeper that we actually fed the corn crop through about double the amount of soil. Where we had cover crops, it was about the top 16 inches. Where we didn't have cover crops, it was only about the top 8 inches. And so that's just one of the reasons I think it shows, what we're getting, why we're getting these better crops than what our neighbors are. And then the big thing to take away is temperature as well. When I travel up in this area of the country, I hear a lot of farmers talk about, well, I don't like cover crops because my ground's going to be colder in the springtime, and I'm going to have to wait to plant. And it's actually the opposite. Julia talked about it earlier. The big thing is, one, there's a microclimate there. That's kind of how it was explained to me. By having that cover crop residue, that ambient air temperature, that cold air really can't push down on top of the soil profile. The CO2 that's released by the biology is also creating forms of heat. So we're actually seeing our ground actually warm up faster in the spring and then actually maintain a more constant temperature throughout the growing season to where we're actually conserving moisture when we need it. And so AquaSpy put this together for us. One of the things that we found out is with cover crops, we actually had about 7 to 9 more inches of crop available moisture. That actually went into the crop during the growing season. It was actually transpired into a better yield. And then the other thing was the nitrogen credit. When we used the Haney test and we were actually able to save nitrogen, we saved 100 pounds to the acre. So where we had to cover crops, we applied 100 pounds less. That's roughly about $45 to $50 an acre in savings there. And then just based on what he saw from the sensors, they were making a projected yield based on our planting rates and everything. And so with cover crops, they guesstimated 220 to 240. And then without cover crops was about 160 to 170. And so they had somebody run through our yield maps. And the black line in the middle is the division line of where the check strip is on the right, and we had cover crops on the left. And the one thing that we kind of noticed that was cool is even where the check strip is, we saw a little bit of yield actually increase in the check strip. I think it was just really that check strip conserving moisture and the moisture moving through the profile, and it kind of bled over a few rows whenever we were picking. But we picked 208 bushel corn behind the cover and 187 without. And so if you start looking at the yield difference, even at $4 corn, minus the fact that we didn't apply as much nitrogen, we made about $120 an acre more net. So our net return was $120 higher, which is, pretty big for what, we're seeing commodity prices at right now. And so then we do tillage plots. That's a thumbs up. Ray Archuleta actually called me one day and he was like, "Hey, what are you doing?" So I sent him a selfie. I have fun with Ray. But, we do tillage, and the tillage that we do is typically for the university. And it's kind of hard to tell in this picture, but if you look at the very back of that disc, that bar actually bolts together and it's broken. That disc had set so long a tree had grown on it. And I had to take a chainsaw and cut the tree out of that disc for us to do this plot for the university. But we tilled a couple acres, and the university said, "Oh, your beans are going to come up better and faster, and you're going to have a better stand." And I'm not going to lie, the beans that were planted into the disc ground, they came up faster, the stand looked better, and they died the fastest. I mean, it looked really good for a week or two, but when it got hot and when it got dry, the cover crop ground with no till, I think those beans ended up making like 30 bushels better. We just, this last year, I think we were like 100 and some degrees. I think in like September the 15th was actually like July the 74th is I think what the joke was. It was just a bad year, but sent Ray here a little picture. And then, don't get me wrong. I'm kind of like the rest of y'all. I think tilled dirt does smell good. But at the same time, you might get smacked in the back of the head doing this right here. But I never know how this one's going to turn out when I show that one. Nobody threw anything, so we're good. But, understand that, as a farmer, it was kind of talked about earlier when Frank was up here. Farmers are creatures of habit. And, 90% of the time when I go talk to somebody, they don't want to change either because of economics or social. And most of the time the social is my dad won't let me, my grandpa did it this way, my great grandpa did it this way. And, the biggest thing that I like to say is the generations that farmed before I did the best they could with the technology they had. And it's my responsibility to do the best that I can with the technology I have. So don't let somebody that did something in the past, make you do it the same way. So this is our tillage plot. All of these plots, these 4 plots are no-till with cover crops, except for number 2, and number 2 is the square plot. And so what we did is we did 0, 50, 100, and 150 pounds of nitrogen across these 4 plots. And so the one thing to take away is the tillage plot did the worst with no nitrogen. And when we put 50 pounds on, it did a lot better. And 100 pounds, it did a lot better. And the maximum yield we got out of the tillage plot was with the maximum amount of nitrogen, the maximum amount of inputs. But where we made the most money is where we had no nitrogen at all. Our 3 plots where we had no nitrogen did 130, 155, and 185 bushel corn. How does that happen? I was told when I started farming it took 1 to 1 1/4 pounds of nitrogen per bushel. That's what we had to apply as farmers. Our typical farm, I'm not saying that we don't use nitrogen at all. We typically put 60 to 80 units of nitrogen on. That's my whole nitrogen program now. And my use efficiency is about 0.3 pounds. So for every bushel of corn I raise, I'm only putting on between 0.25 and 0.3 pounds of nitrogen to grow that bushel of corn. And, there are some years that we could cut back. There are some years I think if we put a little more, we could yield more. But when it comes to the economics, we're just trying to make the best return on investment. And so one thing I learned is everybody asks me if I'm living a dream. I say nightmares are dreams too. I figured since we were in Wisconsin, I'd talk a little bit about dairies. We started renting a dairy farm. The dairy farmer wanted to retire from the row crop side. And one of the things he told me is they had this great thing called a slurry store, and I got free manure from it. I could apply it to my fields through these traveling guns, and it was great. And so the first day that we rented it, I went out there and the pump was about to fall off, and it looked like there was bubble gum and duct tape holding most of it together. But one of the things that we found out is, manure has worked out pretty good on this farm. They don't let their dairy cows out to graze. But the biggest thing that we found out is having those nutrients available, the timing that we put them out there is very critical. I guess I can get away with it a little better than what y'all can because our ground doesn't freeze. We can still apply manure in the wintertime, but think about when you're applying this manure. If your ground's frozen over and you're going to put it out there and you know that it's going to run off and you're not going to get it in, you're pretty much wasting your time and money. And we've got to think about these water quality issues. When we started farming this place, there's a pretty nice pond on it, and every year they were putting copper sulfate in the pond because they would get these algae blooms on it. And as we started changing the timing and the rates and how we were putting this manure out, it's really changed some of the water quality, even what they've got on the pond. And so one of the ways that we started doing it on our farm was looking at how we're grazing our animals. If you are doing rotational grazing, just remember the most productive part of that forage is the top third. So on our farm, we're taking the top half, we're taking 50%, we're maximizing, but the cow gets half and the ground gets half. And I understand, most cattle grazers, they're going to see all that grass and it's pounds of beef and we're going to want to put it on an animal. But just understand, if you'll allow that to go through a rest cycle, anytime we take more than 50% of the grass, we're actually cutting the rooting depth, which actually delays our regrowth time. It actually changes what our forage quality is, so we're going to have a little less forage quality on the next graze. And don't get too caught up in making your paddocks straight. So many times I go to guys' farms and they almost want to put a laser line on making that line straight. It doesn't matter how it looks unless you're worried about what your neighbors are going to say. I really don't care anymore. But don't kind of lock yourself up. I mean, I'm up here in Wisconsin with y'all for a week, and I've got cows back at home. And really all we did is we put out a few hay bales, and I opened up all my paddocks. They can go anywhere they want to, and when I get back home, I'll pick a place to start them again. That's the paddock we'll put them in. They'll be there for a day or two, and then we'll start back on our rotation. Don't really think that you got to hem yourself up and make this harder than what it really is. And so this is what it looks like after we move them and graze them. So the regrowth on this first paddock here, the one that you can see right now, it was actually grazed probably about 3 to 4 weeks before this. And we'll typically have anywhere from about a 40 to a 45 day rest cycle before our cows see the same piece of ground again. And we're just using water tubs and pulling them around, and it's working out pretty nice as well.